My name is Shikha Pathak. I am the Manager, Awareness and Skill Building at SciSec. Welcome to today's webinar. This webinar is a part of SciSec's weekly series titled Samgacchadhwam, May We All Progress Together. The objective is to cover various cybersecurity topics and provide conceptual overviews. Let's start with some ground rules first. All attendees of the webinar will be on mute by default. We will have a question and answer session at the end of the presentation. In case of any questions, please share them on the chat window and the speaker will respond after the presentation. We will be recording this webinar and the recording will be uploaded on SciSec's YouTube channel, so you can revisit it anytime later. This is the 30th webinar. The topic today is AI in cybersecurity. We are sure you will find this series of webinar very useful. Here is a list of the upcoming webinars. We have opened the registrations of some of them on our website, and we will be sharing all the updated information on our social media channels. In case you want to access previous videos, you can head over to SciSec's YouTube channel. All the recordings have been uploaded there. As usual, we will be having an assessment after this webinar, which will be kept open for 60 minutes. The questions will be from the topics which are already covered in this webinar. Those who get 7 or more than 7 marks out of 10 will be provided with a certificate of achievement. Those who are unable to take the assessment will be provided with a certificate of participation. At the end of the assessment, you will also be asked to provide feedback. Please provide your genuine feedback and be assured it will have no bearing on your assessment. The link of the assessment will be shared in the Q&A chat session. Please note that this assessment is open only to those who have participated in the webinar. Let me now take this opportunity to introduce today's speaker. We have with us Mr. Florin Manela. He's the Senior AI Architect and Inventor, Cognitive Systems. Mr. Florin works as a Senior IT Architect and Inventor in Germany for IBM Systems Division across Europe, Middle East, and Africa. He has over 20 years of work experience, concentrated in information systems design, business security architecture, enterprise risk management, information assurance research, and business consulting. Florin leads enterprise transformation by adopting high-performance computing, distributed deep learning, and emerging technologies. He is passionate about memory computing and spiking neural networks. His client experience covers European Union commercial and government, civil, and defense agencies. I am sure you will have a lot to learn from today's series. Welcome, Florin. Now over to you.
Thank you very much. Let me share my screen now. I hope you can see this. All right, so thank you very much. Let's start this. I will try to present, as you mentioned, the way we apply artificial intelligence in cybersecurity operation and how those things are progressing as the AI field is actually progressing as well. And before to jump, I added here a warm-up exercise. And just to start to make you think on the things that we want to tackle here, right? So just try to imagine what a bicycle looks like, right? So if you see here, we have seats, frames, brakes, wheels, chain, pedals, and so on and so forth. So there are some characteristics of the bike, right? And if you try to think beyond that, and if you see those images, you can recognize them as human, as being bicycles. on different shapes, maybe too futuristic or damaged bike, but we can do that, and nobody really, had to tell us and give us hundreds of examples of how, for example, a futuristic bike on the right corner can look like in the future or something. We can imagine that, right? And all those things, they share the same characteristics, the same features. For example, wheels, right? Or a seat where a person will have to sit on the bike. And we have to remember this for upcoming slides, how we extract this information and how those things are being used, those features, into identifying, for example, an attack vector or anything else into what we want to predict. So one of the question is how we take actions. And in general, as humans, we have informations. And then we process these informations. We have the readers, so we get the information via eyes, via sound, and then we do the inference based on our knowledge. And that was defined prior to the process that we want to actually tackle as an action. So if you try to see here, we have the artificial intelligence. There are various definitions out there. If you look on the Webster dictionary, they define as a branch of computer science dealing with the simulation of intelligence behavior in computers. If you look to Oxford Dictionary, where they elaborate a little bit on the basic definition, calling it the theory of the development of the computer systems able to perform tasks normally require human intelligence, such as visual perception, speech recognition, decision-making, and translation between languages. And this is interesting because you see many kind of definitions, but all of them, they actually speak about human mimics, right? So this is interesting. And then there is another field of AI called machine learning, where manual features encoding or domain knowledge is needed. Faster computation, seconds to hours, can work with small data sets and can explain the outcome. This is mostly what we actually see right now applied in majority of the industries where they do kind of analytics and they apply machine learning to do more things about that. And then we have the deep learning or neural networks, where it's a class of machine learning, right? The part of it. With many layers, we have those neural networks with many layers, more abstractions in deep layers. We have the automatic feature detection, which is very important. We have it's computationally intensive, can lead to weeks or months of training. Requires a large amount of data in a range of terabytes or maybe hundreds of gigabytes, depending on the task. And it's very difficult to explain the outcome. So this is interesting, and I will speak more about the deep learning as is presenting of great interest. And then we have the representation learning, which is actually trying to learn those features in an automated way, something between. And obviously there are some others, but mainly I'm going to cover some topics from these things. This is not new, has been published in 1950. By Turing, and you see here, for example, the three characteristics of the human mind: the initial state, the education, so that will be the training of a neural network, and then there is experience, not to be described as education, in which the subject is being exploring the new data, the new form of, say, perception. And this is interesting because this is the technology we want to apply today when we speak about AI in this particular field. And for this, we need data, a lot of data, and we're going to speak about this. But I can say that there are mainly two ways of getting the data. One is from existing database and so on and so forth, so structured way, or unstructured from kind of, system logs, application logs, social media, anything you can imagine that can be thrown somewhere into a into a big data lake, and we can extract that. So these two things we can tackle. And then we have the training time as a process where we need to get those models and feed the data into them, and they will learn either to classify the data, either to find new patterns into the data, and so on and so forth. And after we have those models, then we try to save those trained models and use them as an inference. I would like to mute, if you're possible, your microphone, please. So this is something we want to do, right? And again, back to 80s, we had this concept of neural network model with hidden layers, with input and output that we're actually using right now. So again, something that has been written in the past. We didn't have in that time the power, computing power, and enough data to do this, but now this is very much possible. So how these things are going? In general, this is for you to see, how a neural network is trained. So we feed a lot of data, in this case, images, which are matrix, depending on the resolution and so on. But we feed those images. We have an input layer, which is collecting then the data. Then we have those hidden layers where we try to identify then the pattern, and obviously the output layer where we have the outcome. In this case, it's just a simple classification, cat or dog, but this is a way where you feed hundreds and thousands of data samples, and at the end you say, well, this is classified correct or not, and those activated neurons or weights, they will be adjusted during the training part as they will be progressing to have a higher accuracy level. So this is very important for you to understand. So we don't explicitly program what has to be learned. The network will learn automatically by giving to the network a lot of samples into this supervised learning process, saying, this is a cat, this is a dog, and showing this over and over and over again. At a certain point, the neural network will learn to identify them correctly. Compared with the standard process where we have to program things where in the pixels they should look for things and so on and so forth in order to identify that. So it's much easier process from this perspective. And this is a training process, and when we have this defined, and when the neural network will provide the accuracy we want for the specific case we are looking for, will provide the less errors. We can save that and then serve that into the production. We call it inference, where new images will come or new data is coming. It will going to have a single process, a single way of forwarding, and we're going to get the prediction, hopefully correctly. And that is something we are then package, and I will have an example how we package this. And we put it somewhere in the production to predict, for example, a threat, to predict an attack, and so on and so forth in such cases. This is an example of the Google Net Class Activation Mapping model. You see up here the structure of the model with hidden layers and so on and so forth, pooling, for example, and so on. And then there is a graph structure of it, so of this network, to understand that this is a little bit different from what we are used to in typically machine learning. Right, so why now? We started in 2011, I think, where those neural networks, they had something like 26% error. And then you have to always try to compare with the human experience, which typically for a good specialist in day-to-day job will be almost 5% error according to the research papers out there. And then in 2016, we had a good model out there into this context based on ImageNet, where we had 3% error for classification, so above the human error for that particular task to identify some specific object. Which leads to a quite interesting approach where I can really say, well, that's really useful. I can use it to some task into my organization to automate things around. And this is an example of image classification for the Stanford dataset, which is based on ImageNet. You see it on the right. I added as well the link here where you can go and search more for object detection, for semantic segmentation, and so on and so forth. Where you see the progress of those neural nets from 2008 and until this year, how those were progressing in terms of percentage of accuracy, right? So it's really interesting to see this progress going forward linearly almost. So that being said, is something that we can apply today in any kind of industry, including cybersecurity. Right, so if you look now on the cybersecurity operations, first of all, you have to look a little bit on the definition, right? And here you have a definition from Wikipedia, which is touching almost all the things. So, it's computer security, cybersecurity, or information technology security in the protection of computer systems, networks, damage of the hardware, software, electronic data, and so on and so forth. And this is captured into cyber threats, which they start to becoming a global risk for almost any entity, private or government held, and so on and so forth. And this is interesting because it's something which is touching everything that we build within computers, right? And obviously, if you look behind that and try to understand what are the security actually assets, vulnerability ontology, and you look here this on this picture, just not from a research paper, which was their ontology approach for applied to information security and trust. There are many things when you want to really identify a risk that you have to take into consideration, or when you look for a security event, like what is preceding that security event, what are the vectors of the conditions, what vulnerability have been exploited, from where, did you have any patch to protect against that vulnerability? So you need to take all those things into consideration. And if you want to expose this into the fact that you can have all this data from your enterprise, which can be small, or your organization can be small or can be big, the question is, how you can do that into a proactive way, or to minimize the time you are doing this analysis, or you actually prepare your next steps, for example, in case of information leakage or illegal access. And this is interesting because as the connected devices are growing and the applications are growing more and more and more, and now we have as well edge computing, things are becoming even more complicated, even for people where you have, for example, a security network operations center. They always tend to look into some devices, analyze events, and try to filter those events and take some actions. And this is taking a lot of time, especially with so many tools. This is another interesting thing I captured on countermeasures against this kind of attacks. And you see here, typically you have some security defense ontology where you have some practices, you have some rules, you have based on the systems you have and so on, and then you have defined some countermeasures against those attacks. And then you have people involved in the decisions and writing them, those countermeasures, based on your organization defensive components. And then you supposedly answer successfully to an upcoming attack. That typically they tend to explore new ways that have not been documented so far, and this is interesting. And what's happening in the last period is that those attacks are more organized right now. They are coming for many persons involved in that attack, instead of in the past a single guy was doing this kind of attack. So they tend to be more complex. As we can see, typically those kind of attacks, they have as well a security attack ontology. And this tends to start using AI, for example, in the last period. And you can search through internet, there are many examples where you have a little bit of intelligence into this attack kind of thing. For example, when you scan for vulnerability a host, typically you are getting something from the scanner as a response from the host, and then you do something else with that response. But what if you actually combine that kind of scanning technology with the information which is out there about the organization? Therefore, for example, you get information, you feed information into a machine learning for classification about what kind of technology that organization is using, and therefore your scanning process will be much more targeted towards to the devices that you identify being used in that organization, just by presenting them on events and so on and so forth, where people are doing this as a reference point. And this is interesting because this is evolving to something new, right? And we have to find solutions how we can really fight with these things and protect. So how AI can help? So first of all, it can help by learning. And when I'm saying this, I define it here as trained by consuming billions of artifacts from structured and unstructured sources about events, about similar attacks in the future that has been happened, and so on and so forth. So when you try to define your ontology as a best practice for defending your organization, you have to be based on what's going on out there. And you need to have this kind of information, those kind of assets to start being built in your organization to improve the knowledge in regard to the cybersecurity threats and cyber risk. The second point is reasoning. You want to have some insights to get out of this kind of knowledge that you build, to identify the relation between the threads. Just give an example, we had an organization here in Europe, they were looking to correlate the events from applications, from servers, from network, to identify whenever they've seen some high CPU utilization on a system. And they want to identify why that is happening. It's coming because of a patch, it's coming because of an attack, or a user behavior, which is strange. You need to have these kind of things because there are so many logs right now, so many systems. It's really hard to be in time with your reasoning. This is too much. Now there is another step, the third one that AI can help. It's augment, right? So you will want to have as well some kind of additional things to provide to you in risk analysis, to reduce the amount of time that you typically need to when you actually want to answer to a critical decision regarding an attack going on. You should pull up the server off, or you still analyze the event to track back the attack and further on and so on. So you need to have some as well some insights about what you should do next based on things which are out there. And typically people are doing this, but it's good, and you take some data points when you calculate your assessment, and you say, well, this will be my decision. But what if you have additional data points that you didn't take into consideration about that attack vector? And here it's interesting to see the AIs actually can step in to give you more information. So a couple of things regarding the machine learning algorithms that can be used for cybersecurity. The first two here, regression and classification, are mostly for supervised learning, and you can detect correlation between different data sets or different threads, or you can classify, for example, some attacks being relevant for you or not relevant. So you can have more focus on the more relevant things which are important. For example, here in ransomware, which are very important when you are dealing with, locking down systems, data, and so on and so forth. And then we have clustering that can, is more for unsupervised learning. You just send all your output from your, let's say, campus organization, for example, all the logs and so on, and you want to kind of identify patterns inside there to see, where you should maybe invest more time or you should protect or what's going on there. There are as well kind of dimensionality reduction I added here for more generalization things, most important for features in multiple examples. And more interesting is generative models that can, create additional vectors of attack, additional conditions that you didn't have into account based on your data point. And therefore, this can present additional knowledge base that you can add to your knowledge base or ontology for answering to attacks when you create your policies. And this can be typically for machine learning and can be as well for deep learning. So you can generate data, you can generate as well images and so on. You will see an example. Here is an example for random forest classifier. On the left side, we see kind of training process, assuming, here we create just a dummy data set that we train, and then we save the model that we train with a good accuracy that we can then put in the production to serve, for example, for classification. You see it on the right side, for inference into a different kind of system called IC922 based on some specific, some dedicated accelerators for inference, but can run as well on the CPUs. So this is two kind of process, two approaches: train, assuming you have your data set, and then you actually deploy that file into the production, wrap it up into some APIs that you can call or send the data in the real time or in batch, as we will see in a few minutes. So I was mentioning about another process of deep reinforcement learning. So try to imagine, where you are playing on the console and you learn when someone is killing you on a game, and then you say, I will not go there next time, I'll go on the right side. And this is Space Invader, a very old game. But it's interesting that the deep reinforcement learning can really work through this kind of game and can learn experience and can really succeed to finalize all the episodes. And if you try to make a parallel on that, you can say, well, I can have something like this for scanning hosts for vulnerabilities and learn about them, and learn about the feedback, and then do something else next time, and so on and so forth. So this can be applied as well for you to find new patterns, new vectors on your organization that have not been documented as well. So this is deep reinforcement learning based on the word approach. Another one I was mentioning is generative adversarial networks, or called GANs, where typically you have a data set, curated data set. In this case, is an example, a simple example with cats, where you actually feed into a discriminator, and this discriminator has to actually take two inputs. One is the real images and one is the generated images from a kind of latent random variable noise or variable space. And the goal is to detect from whatever is fake to what is real. And with the time, the generator will be so good that it will be very hard to distinguish between a real world image and a fake one. This is typically happening, at least on the image space. But then you can use this discriminator, so only take the half of the part of the network that is generating data to actually produce output for you that you can use either for training additional things or to identify or to create new attacks vectors in your organization to detect where are the breaches that you cannot see them. So that can be used as well in such cases. Now, if you're looking for some threats, attacks in camera security, I'm sure you know all these things. So malware, data breach, social engineering, which is quite interesting because social engineering is actually getting a lot of information about your organization, try to exploit them from outside the world, and then try to go on different things. And here you try to apply machine learning and deep learning. You need to have something like, okay, what I do when someone is calling in a call center, because everything is on voice, how I can detect things running on sound, on voice, and so therefore sound detection, and analyzing what's going on there based on previous calls and so on. Or, for example, if it's a video, if someone is showing up into organization just to change, for example, a couple of hard drives into a storage, how do you know that that person is really the person that is saying to be, and so on and so forth, which is more like computer vision analysis and so on, and additional things. And then there's more interesting things like phishing, structured query languages, SQL injection. This is typically the field of machine learning. Denial of service attacks, from where they were coming, how they are coming, what is the bandwidth usage, what they are tagging, for example. And this is something that you have to take into consideration. Then you have the inside thread attacks. There is a big theory that majority of the attacks are starting from inside. And then advanced persistent threads, things which are still, coming up, but they have different kind of mechanisms, very complex mechanisms, looking at your network, collecting informations, and so on. So how you can really have some algorithms that can really tackle this. So, for example, you see a stream of events of gathering information from your organization, like scanning and so on. And then you see another series of events by looking by strange codes to your help desk organization, and how you correlate those things as being, kind of anticipating an attack or something that will happen in the future. It's interesting to see this because people, they tend to look only in the IT, into systems, what's going on there, but there are so many things that can happen when you actually correlate the data or you extrapolate the data from what's going on out there in additional channels. Then we have the where we really try to apply this. Obviously, in the organization, we have the intrusion detection system, prevention systems, where people that are really showing a lot of let's say in this case logs. We had an organization, for example, they were collecting logs at the rate of I think it was around 10 gigabytes a second. So one of the questions is how you can really be sure that all these logs that you collect at that kind of throughput is really try to see how these things can be automated when you look for some particular event, because to analyze that 10 gigabits a second throughput is very difficult. It's really very difficult. Even if you have 20 persons there or 10 persons, it will be very hard for them to take a look at, even if they have the best systems. Malware is the same thing. How we can really understand those malwares and what they are trying to do without having a prior knowledge about those malware. And this is another interesting thing, because people, they tend to say, well, just malware, I will have some kind of antivirus to deal with this, or probably to do it, to cache that at the network level into the network pattern. But this is not always the case. Spam, social engineering detection. Again, this is what I was mentioning prior regarding the natural language processing, right? So we have calls in your call center, asking for several things, or just normal phones into the IT help desk, and so on and so forth, and how you can really analyze those things, what's going on there, if someone is requesting information that should not have, and so on. or it's trying to trick the people which are on the other side. And obviously the network traffic analysis, which it's a topic there on trying to use, for example, a neural network that will detect by looking to the BGP routes across, for example, large organization, or if you have OSP routes, how those things are changing, how your links are going up and down, how the traffic is moving around. Or it's increasing. This is as well something which is interesting to have a look at. And for example, for spam here, I did a link from Google where they exactly mention how they use one of the machine learning framework there, which is TensorFlow. They open sourced for their analyzing more than hundreds of millions of spams and so on and so forth. It's interesting to read that and to see how this is progressing from statistical program things. You know, if you see those words, this is spam, and then you have some ranking and so on, to more like a natural language processing base of those emails. Then we have the process behavior analysis. This is quite interesting. I was involved in one project 2 years ago to find anomalies for causing some processes to consume more CPU cycles. Because typically when you have a system and you see that process going up, you say, well, maybe it's a patch, or maybe it's a bigger utilization from users. You don't have the whole story behind. So we are trying to look for identifying this kind of behavior with some machine learning models. Then you have the user behavior analysis, which is more towards to users. Just for example, if you have majority of your users are connecting between 8 o'clock in the morning and let's say they log out, let's say 6 or 7 o'clock, and then you have a user that never log in, you know, at 1 o'clock in the morning, always was coming at 8, and suddenly he's just logging at 1 o'clock, right? So we need to catch this kind of thing in an automated way. And there are many other examples. Then more on the computer image side, flying drones detection. Let's say you're a government entity or manufacturing, and you have you don't want someone to steal your information, or you have some data centers or some specific networks there. So now you can have a drone that can automatically be, you know, programmed to fly in that region, make pictures, make videos, and then fly back with information, or more to be encountered with equipment that can really read the data or just try to create issues in the networks by, you know, jamming the network and so on and so forth. So that's, you know, how you can detect those kind of things. Physical security deviations, you can name it a lot. I have one example in a minute. And then finding unwanted electronic components, for example, on the computer boards, right? So this is, for example, if you are a supply, how you can really check, you know, if someone didn't attach something to a specific board from the manufacturer until that reach your data center or your prem on the chain. So how you do that kind of inspection or audit without, you know, having that kind of knowledge, you know, of what's going on those kind of boards. So I was mentioning this is an example of finding flying drones where, you know, just having cameras that can detect those drones flying and then just inform about the position of the drones, where they are, and then you have kind of another system that can take decision. Okay, let's go there. And there are several other systems to shut down those kind of drones. And this can be very easily added to those kind of facilities because they have the CCTV there in place. Another thing for physical security is enforcing about people having the badges and the right badge. So we can have models that can be trained to detect if a person has a badge on it or not. It's interesting because there are some organizations that they are really interested to see these kind of things and to be alerted if someone doesn't have the badge in some very strict areas. I was mentioning PCB boards. This is an example where you can have a camera looking to a board to identify other defects or other components that was not supposed to be there. So this is the kind of what you see here in the image is just object detection for those pins which are not aligned correctly. But you can have, for example, you can think that you can have an image of the clear board and say, well, you know, this is a board should look like, and if I see another board that has an additional component capacitor there, and that is not the correct board that I was expecting, which is a classification case. And as well, this can be used for identifying those kind of threats. More things from, if you look from the satellite perspective, can be used typically in defense, can be as well used in agriculture and other fields as well. Satellite images for classification, object detection, so to understand more, you know, what's going on there. And this as well can be applied with deep learning. Now, how we put this in practice? This is an example where you can go and download this data set. This is a data set used, I think, exported from our intrusion detection system. And if you look inside the data set, you will see the data about the application layer, the transport layer, the network layers, as well as additional information from intrusion detection system, like, you know, big normal traffic or a specific type of attack. And when you actually try to see in these kind of things, you will see, you know, if you look more and you open those files, are big CSV files, or depending on the system that, you know, the capability of exporting them. You have all this information. For example, if you look onto the transport layer, you have the IP address of the host initiating the connection to the destination. You have the information about the port, if you want the type of application which is going on there, and all these things. Then this will translate in a file like this, right? So try to imagine that we get access to hundreds of megabytes or gigabytes of those kind of files. And you don't have either you have the tools, but for example, the monitoring tools typically are decoupled from newer technology. So if you have some monitoring tools in place to look for some things and you add, for example, a new device on your network, that new device can have a different format or can detect different things. And then there is a gap between the moment you add that new device in your organization until the moment you can really consume the logs in the way they should consume by your monitoring system for security threats on your organization. So it's very difficult, even if you have those tools or if you are really looking manually to look line by line of all these things. Especially with so many kind of attacks that can be there. This is just an example based on this example here, where you can see here, okay, I've seen a rootkit activity there, and then you are interested to see, well, where that happened and what kind of rootkit was there and from where was initiated and at what hour and so on and so forth. So you want to identify more things. So you can create either machine learning algorithms that can look through this kind of data and then correlate the events data, for example, for some from rootkit activity to some event that can be to that specific time, hour, and from a user activity, right? So you can have something like looking for logging activity in that kind of hour or service activity and so on and so forth. That means that you need to do feature engineering, right? So you need to reduce all those number of features to a couple of important features that you are looking for as a data scientist. And then you have to classify them, select the right models for you and the right features, and then build your pipeline for training. And then hopefully you want to do inference if that is successful. And this is very hard, and it's not that easy to do it, especially when you speak about those huge logs and multiple logs on multiple systems, especially if you have even IPv6, you have so many devices. And For example, this is a basic feature for TCP/IP connections. So you have the duration, protocol type, service, flags, lands, urgent, it was an urgent, packet requested. So you are interested, for example, to say, well, in that connection, I will look for these kind of things because I know that for specific attack that I'm looking for, I have some insights. I'm looking for package which they have the urgent or they have a specific flag inside. So you'll do the query starting from there. But to do this kind of thing, you need domain knowledge. You cannot take, for example, data science, which is very good of writing algorithms so on, say, hey, now you are doing security things. Because he needs to understand, what is inside of the data, right? What kind of those flags are doing, what you are looking for regarding some features regarding the TCP/IP handshake, for example, and so on and so forth. Or if you're looking for those attacks about the SIM flooding, what is actually you are looking there if you want to define that. So you need big domain knowledge when you apply machine learning. There are as well other kind of techniques like automated machine learning I will mention at the end that can extract automatically from a specific things where you actually give some informations about what you are looking for to extract the most important features for you. Yeah. And that's it's another kind of story, but that is possible as well to automate the whole feature extractions for you, and even identifying the best model that is suitable for that particular use case. Traffic feature computed, here's another example from a table where you have this information and you have to understand, again, what you want to take into consideration when you want to do, for example, a classification, right? So to detect those abnormal events where you have a high sensor rate, high SIM rate of packages. And how you correlate that with time or with another event on your organization. Just because seeing packages more and more errors, that means that someone is either rejecting them or is trying to initiate more and more to flood the system by opening additional connections. At the end, if you try to extrapolate, majority of the systems that are doing monitoring, they are doing CM or do any kind of monitoring and logging capabilities and give you the insights, they will try to really give you, the true positive, false negative, and true negative, right? So this is as well something that you can achieve with machine learning by programming this and try to find, for example, the true positive things in your organization and ignore the true negative, right? So this is something as well that you need always to take into consideration when you build that, and try to see how many events you have in a specific range. Let's say in this case, how many true positive do you have by looking at the confusion matrix. And this is where you should actually look for, more investigation, you should put your attention and so on and so forth. Yes, there are a lot of systems offering that, but the question is, what is the capacity of those systems to adapt fast, compared with having some data scientists that they will create those things ad hoc based on some requests which are coming immediately from the management. Another example here is about AI pipeline overview. It was published in a research paper about how you process this information, how you extract. You can see here about training the data set with a couple of features, trying to reduce those data sets. Typically, you actually split those data sets if you have a big data set, you have to split it in 80%, for example, training, 20% for testing, and then you need to have additional data for validation. And then here is another thing is about the classification, which is back to the confusion matrix, which is, again, this is something that we want to do it on the network, to classify the events first of all, and then you want, if you do, for example, a simple classification. But there are cases where you want to do, for example, clusterization. So you just feed the data into an algorithm and then you should get an output. Well, those events were kind of similar. On the other events, they were as well similar, but we found as well some events which are not that similar, and you should more look in those kind of outliers here. Right, so moving to the enterprise, what do we have and what we need to put on in place to serve these kind of things, right? So first of all, we need to have a policy of building this kind of data lake or store this kind of logs from anything which is moving in the organization. So from system logs, from networks, from switches, from firewalls, intrusion prevention system, anything, email system, anything there. Because any information landing into a data lake will be useful for data scientists by investigating something. And this is important because whenever you store the information into a database, you trim that information down to the database schema, and therefore you lose information. So this is very important to actually have this store even for history, because you need a lot of data to train those models. And then when you train them, there are cases where you spend days, hours, or you may spend even 2 months or 3 months. And therefore, you need to have a policy of distributing computing across multiple of systems when you do the training and even processing the information, so transferring the information. Machine learning and deep learning, you need to create a strategy around the frameworks that you want to use. You want to use TensorFlow, you want to have PyTorch capabilities, or you need some additional kind of machine learning algorithms. This is an example of SparkML, NapML, for example, can be used with or without GPU acceleration and so on. And then as inference, you want to consume those models, you need to expose them in-house or externally to be consumed somehow. And the best way is to wrapping that into a container, these models with the running times to serve them and try to serve those models further on to applications or kind of form of microservices strategy. So how we get those predictions? In batch AI and in online AI, we say. So batch AI is like, you send all these things to a system, and you have a model there, and you train that model for a couple of hours and days, and then you get the result. In online AI, you actually move and you say, well, I have my model, it is ready to be deployed in the production. That is the inference process. I need to be real time. I have to interact in real time with the data coming. And that has a different thing. If in a batch AI, you don't care too much about the latency, you care more about throughput. In online, you care about more about latency. You need to do the inference. You need to respond in under 1 second, right? So that's very important. Two different things, two different approaches that will go and will lead to different kind of systems and software that you need. For example, here you see IBM, it has two systems. One is called IC922, that we can use it for preparing the data, for storing the data, for example, based on Hadoop on the left side, and as well we can use it for inference. And this is equipped with up to 6 NVIDIA T4 GPUs, and is massively scaled to towers to the I/O part, right? And this is again, something that you have in the strategy as well when you try to say, well, I want to train. And therefore, when you want to train, you have this vast amount of data that you need to take into consideration. And for that, we have the AC922 system that, again, can be equipped in the water-cooled version with up to 6 voltage GPUs. in just 3U, and is the only system in the world right now connecting the processors to the GPUs via NVLink. So you have a huge throughput for the I/O. We call it the most advanced I/O system, balanced I/O system that it's out there for training. So again, this is important when you feature, you try to do your architecture. Now, the flow here, as you can see here, is typically you have those various data sources that you're trying to take them. You need to have a lot of time preparing. If you do, for example, supervised learning, you need to prepare your data. And typically people, they spend a lot of time, more than 40%, 50% of their time they're spending on preparing the data, which is very heavy I/O process. And then you move to training your models, finding the best models, finding the best hyperparameters for them to achieve the accuracy that you want. And while this is finished, then you actually deploy them into the production. And it's interesting, when those models are in production, they create new data, or we call it metadata. And you have to capture that and put back that as a new source of data that you have to take in consideration in the future, because there are actually events coming from a piece of an algorithm which has some intelligence inside. That's interesting to see. This is a continuous process that you have to apply across the organization in the security practice. Another product we have is a software product that we added to those systems. It's called Watson Machine Learning Community Edition. There is an open source of it right now, open source called OpenCE, Open Cognitive solution. It's available on Git and it's available on the Docker Hub. It's available on the Conda channel, where you can really consume those models in those libraries and frameworks. So we include TensorFlow there, PyTorch. We optimize them for operation on our systems, including the needed CUDA libraries, additional CUDA primitives, and so on. So it seems that there is a problem with the sound.
No, Florin.
Okay.
Fine now. Thank you.
Okay. And then we are trying to serve as well the inference side, so not only the training. So we include the TensorFlow serving server, TensorRT. We do have support for Onyx, which is another piece of the puzzle. So all those models, when you try to share them across the organization, the train models, you need to define a standard, how you're going to export them, right? So Open Neural Network Exchange format is one way. There are some others. We believe it's one of the best. But you need, when you go ahead and say, well, I will start doing all these things, you need to define the standards that are going to use in your organization. And we are typically try to incorporate as much as we can into this packaging distribution called the WMLC. And obviously this is for operations on the bare metal. So you just install your Conda, Anaconda on your laptop or on your server. And then you fetch all the packages from our channel, or you go on the Docker hub to take the images that you need. Here there are various versions of it with various TensorFlow, PyTorch versions, so it's like pick and choose. Or we have as well the same thing as the UBI images on the Red Hat catalog that can be consumed as well. For example, if you have an OpenShift cluster and you just want to have a one-click deployment to start deploying them. For computer vision, we have IBM Maximo Visual Inspection. This is a product came, I think, 2.5 years ago, from our called Power AI Vision, where it's very simple to just drag and box, just drag and drop the images. For example, I was mentioning the example with people having the security badges, and then you start labeling automatically into this web interface, and then the training will be done. The system will select automatically the best model for you based on what we want to do, classification, object detection, and so on and so forth. and will produce the model, will give you the best way to expose as well the model by providing a deployment option, so we can wrap up that model into an API and say, hey, here is an API, here's an IP address, here's authentication method where this new model will serve you. So will actually answer, will predict things for you. And it's very easy to be consumed at the other side. So you have to be an expert using the system. This was our idea when we created this system. So something you should have in mind. If you say, well, I don't have data scientists too much here, and I don't maybe have too much time, or I'm spending too much time identifying, because I'm not a domain expert, identifying the best features. There's another piece of the software we have on top of our systems called Driverless AI from H2O that can help you with data visualization, feature engineering, auto machine learning, even can actually give you a report of, explaining the model, why was chosen the model to be trained that way, what were the parameters and so on, that typically you need when you put those models in the production for feature audits. And this is something that it's always good to have in mind. So I'm at the end of my slides. I'm open for questions right
now. Thank you, Florin. For the participants, if you have any questions, please share it on the chat window so that the speaker can take them up. We are finished with our presentation, Murgesh. So we are waiting for the question and answers round. If you have any questions, please share it on the chat window. Yeah, Florin, I think we have one question.
Okay, so there is a question there. What are the major deep learning tools used? So in general, when you look for this, we see more people trying to use PyTorch and TensorFlow, and this is those are open source tools. There's a great knowledge out there, and many examples that you can test. For example, if you look on GitHub on similar things. And then we have as well the standard machine learning, so scikit-learn, for example, NumPy, that you can use them to analyze this kind of data. For example, if you do a classification or regression. Part of those frameworks and libraries, you have the Jupyter notebook and Jupyter Lab and Jupyter Hub that will give you a way to interact with those with this programming in Python, for example, in a graphical way via web interface, either from your laptop or from your server to your laptop. So it's easier to consume and share the output or your notebooks across multiple users. I'm looking here to another question. What are the practical implications of AI in cybersecurity? Well, one of the problems we have is the fact that those deep learning models, we cannot explain how they really work, how they took the decisions. So we know that we train them very well. We know that they perform better, but there is no way we can look them and say, well, why did you choose to classify this event like this? And then we have we have an explanation from the model back. And therefore, this calls explainable AI. And therefore, there is a great research right now. We're trying to find new neural nets that can have this explainable AI inside. There are some practices out there by, sharding every layer and try to identify some things. Or another example is when you classify, can have this class activation mapping where the network will show you the region of interest into an image, telling you, well, we classify this image because we found those features here on the right side, and we'll show you that thing which were contributing the most to the classification. So some of the things are okay. Some of the things they have to be to evolve over the next period, especially on the explainable AI side. Which AI algorithms is well suited for cybersecurity? So if you are into network sites, so you are trying to detect some things, I would say classification is typical things you should apply there. So because you want to say, well, this is an attack, this is not an attack, and so on and so forth. Other questions? Can we incorporate AI in honeypots? So can you please some of that? I don't know to answer on this. Can AI help in doing audit, and can we rely on AI? So this is a good question regarding the audit. Typically, the audit it's done focused on some specific things, right? You want to audit the databases, you want to audit the systems, the storage, and so on and so forth, right? And you have some practice in place. And you maybe have as well a report, a breach security report, and so on. But what can be done in this regard is, I was mentioning before, AI to learn from the knowledge out there. So you can have something like a knowledge base based on AI, where you can go and have a question there in the natural language, right? So and you can say, well, I want to audit, for example, the databases of the system. What are the new threads out there? And that can give you an answer based on blogs which are being collected out there, and so on. Just point you to the reference, and then you can actually be more focused on the work you are doing instead of just using some tools, for example, Snort and so on and so forth. That will be updated, but you don't know exactly how you can focus more or target more your effort. So yes, I think that can be used, especially for focusing more the effort of the people doing the audit. It's possible that AI to eliminate? No, I don't believe at this point. In my view, AI can augment somehow and help people to come with a greater and a better view on the security, and not to actually replace things. At least for the next 10 years, I don't see that possible. Another question, can an AI hack? I don't know that, but I know that an AI or machine learning or a deep learning system can be hacked, which is another discussion, another field of the security right now, where you have, for example, if you have someone in an organization that has deployed a deep learning model in a production, the question is, can you fool that model? Right? Can you present data to it that will not be classified or will be misclassified, or you will lead that? For example, we had a colleague at MIT in US created a T-shirt. So they created a model to detect a person, and then they created a specific T-shirt that if you were wearing that T-shirt, the model was not seeing you as a person, so you are not existing there. So yes, it's another field of involving security over the time. And yeah, those systems can be, those models can be hacked, if you want to say like this. What malware are developed with AI to act as normal function on scanning time and normal function on the other time? There is a chance that detect such threads. I don't know. So to answer to this question, so unfortunately. Just more learning resources on this topic. Yes, we do have a cognitive class AI. If you go there, there are various labs and learning materials. You can really just check and learn if you have some time. That will introduce you from beginner to advanced in some topics. Yes, we'll try to share at the end some topics about explainable AI and some example to some GitHub resource sources. What is the computational complexity of AI in analyzing the network traffic? Again, yeah, when you look on, when you put it this way, it depends on the throughput. Those models, typically what you need is the response time in analyzing, if you want to be real time. The model that you want to use, therefore that model will consume, for example, if you use a GPU, will consume an amount of the GPU memory. So you can have, for example, a model that can serve to 1 gigabit traffic per second, and you can process events. For example, at 1 gigabit traffic per second under 1 second. So that will be your prediction, your response time at that traffic. In the moment you increase the throughput, you may go, let's say, in 2 seconds or 3 seconds. And therefore, in that case, you need to provision another model on another GPU. So it really depends on the throughput you want to have and analyze of the data and the response time that you want to have. And then you have to take in consideration the model that you use based on the accelerators or non-accelerated environment that you want to use. So it's more like a hardware resource capacity. Yeah, so it really depends. You can start with having a simple accelerator and serve that and see what's going on there. Typically, if you just want to detect some things, some attacks, NVIDIA T4 GPU should be sufficient for a very small traffic. All right, so let's take another 2 questions. If you want to study cybersecurity, so along with what is needed to study AI, well, I think there is no common education. Say, if you want to do cybersecurity with AI and so on, you need to study this. I would say you need to have the domain knowledge, which is very important in security, and you have to choose if that is network traffic security, is that it's injection, database, email, phishing, and all this kind of things. So you have to take a feel from there and then study how you can apply that to machine learning. And there are great resources out there how you can really start just firing up a Jupyter notebook and start using some things. First of all, I would start with classifying some events, or if you do an unsupervised learning, just to try to cluster some events. So that's something that I believe you have. First, we need to have the domain knowledge, the cybersecurity side, and in that field, in this field, what you actually want to tackle, and then you need to pursue some machine learning things. There's another interesting question here. Can we deploy AI and machine learning on edge computing solutions? Since edge computing has limited resources, can we deploy pre-trained models? Definitely yes. The only thing we need to take into consideration is the model you want to use. Not all the models you can run successful on edge computing. And the type of the hardware that you use. For example, if you want to use something like a Jetson device where you have an embedded GPU, you can run more complex models because you have this embedded GPUs inside there. If you want to run across a Raspberry Pi, for example, you will be limited as well about the power of that Raspberry Pi 4. Or if you want to run on a microcontroller, right now there's this field called TinyML, where you can run TensorFlow Little on microcontrollers that can do basic things, right? Can detect sound, can detect acceleration, and just do something about it. So always you have to understand what is your target device, what are the limits there, and then you go back and say, well, I will need to have a model that can fit there. And you will start from what you can do with those limits with that kind of model. So many layers or so many kind of operations, and how big is that model, that trained model. Because at the end, you will train that model on a GPU-based system or on a CPU-based system if you want. And then you will try to save that model and then to do the quantization and pruning. So you will try to optimize that model for inference on your device. That will be, again, another thing that will depend on the device that you want, the technology that you want to use, and then put that to run. But you have to keep in mind that it's not just running the model there, right? So you want to run a model, which means that the same device will have to get the data, will have to run the inference, and you have to do some post-inference things, so some decision things, just send a message, send an alert, write something, and so on and so forth. And those additional two things will consume as well power on that device. Right, so right, so I think we kind of finish.
Yes, thank you so much, Florin. I think we have successfully taken up all the questions which were there in the chat window. So thanks a lot for facilitating today's session, sharing your knowledge with all the participants. I'm sure that they would have found the session very enriching. Thank you for being a part of our series.
Welcome, and thank you for the invitation. I just want to say that this is a very big topic. You should dedicate more than a couple of hours because there are so many things to say and so many things to show. Then it's very hard to capture in 1 hour. What I try to give is just to give you an overview and just a way to look forward of innovation on top of typical cybersecurity protection, which is practiced by the specialists.
Definitely, it's a very broad topic, and we would really like you to be back again with another session, perhaps in the same theme. So, thanks a lot.
Thank you.
Thanks. Thank you so much.
Sir.
Okay, so now we will move forward and share the assessment with the participants for the post-webinar assessment.
Ma'am, actually, I started attending this at 5:25 p.m. Is it okay to attend the assessment, ma'am, or